Okay, so we are going to apply now the the Cauchy's integral formula for derivatives for this guy. So let's just notice what's going on with our integrand. Ooh, I missed my DZ. What's going on with our integrand? So this is like, I guess we can factor out a z cubed. And if we do that, we are left with, let's see, z plus 2i is analytic in a domain that contains, simply connected domain that contains c. So that's not going to cause a problem, but z equals 0 is a problem for this other one. So I want to choose to rewrite this as z plus 1 over z plus 2i all over z cubed. So here our f is going to be this one here. So we're dividing by a cubic power. So that means if we want to apply the Cauchy's integral formula for derivatives, we'll be looking at the second derivative. So f2 of z naught is going to be 2 factorial over 2 pi I integral over c f of z over z minus z naught to the 2 plus 1, so cubed in this case. So this is exactly the right form. So what this says is here z naught is 0. It says that we can compute the value of the contour integral by taking the second derivative of f. Now, maybe the value of the contour integral is easy to compute with parameterizations. I don't think that's the case, but I encourage you to try. I think in this case, let's just clearly write out f. I think in this case it's easier to just trudge through the quotient rule. So we have z plus 1 over z plus 2i. So that tells us then that f prime of z is going to be 1 times z plus 2i minus z plus 1, times 1 over z plus 2i squared. So we get, let's see, the z's cancel and we get 2i minus 1 over z plus 2i squared, I believe. Yeah, I think that's correct. And is that correct? Did I write that down right? 2i z plus 1. Yeah, looks good. All right. And then f double prime of z is the next derivative. We differentiate a constant, nothing happens. Or we get 0, so that term doesn't matter. So then we have the constant times the derivative of the denominator. That's twice z plus 2i all over the denominator cubed. Or we could have written this as a negative exponent, whatever. And so I think that, or sorry, squared. Squared is to the fourth, my bad. So I think then we have a cubed in the denominator. And let's see, we get negative 4i plus 2, so 2 minus 4i over z plus 2i cubed. All right. Whew. Okay, so what we're going to be doing here is we're going to be plugging in 0 because our z naught here is 0. So and f double prime of 0 is 2 minus 4i over 0 plus 2i cubed. So that's what, 2 minus 4i over negative 8i, which is like, let's see, 1/4 I plus a half, I think, if you sit there and do that. Is that right? Looks right. Okay. And then finally, that's just computing the left-hand side. Now we care about the actual contour integral. So the value of the contour integral of the original guy was z plus 1 over z to the fourth plus 2iz cubed, which we rewrote as the integral over c, z plus 1 over z plus 2i, all over z cubed, is going to be, let's see, it was 2 factorial over 2 pi I, so it's going to be 2 pi I over 2 factorial, the second derivative's value at 0. So that's pi I times 1/4 I plus 1/2. So that's what? 1/2. Well, it's negative pi/4 plus pi/2 I, if I've done it correctly. And so there we go. Now, that was a little bit of work because we had to compute some derivatives to compute the value of the contour integral. But we have to ask ourselves, do I prefer this work over, parameterizing the contour and whatnot? So maybe you prefer that, and that's fine. But nevertheless, we can use Cauchy's integral formula to compute this. And whatever you get when you parameterize, if I did all my work right, you should get something like minus pi/4 plus pi/2.